Alright, a comment video, just to settle a few things and such. People do say shit, and I suppose I should respond to it. I don't know if I need to show you the commenters, and I don't even think I need to show you the comments, so we'll just read some of them, and that way the camera can be a steady cam for a change, or steadier, perhaps steadier, stay. Yeah, maybe. Anyway, alright, so Representative Press guy, I don't know who recall seeing him before, but anyway, you cannot be correct about light. So he quotes from some article. How fast do we have to move to make it around the Milky Way in one galactic year? It's a huge circle, and the speed with which the sun has to move is an astonishing 483,000 miles per hour. Yeah, well, frankly, these equations are usually based on something like redshift, which is a big mistake. So, and if the number's true, okay, it's fast. It's let's see, miles per hour converted into miles per second, 60 and then 60 again. Yeah, I hate doing this. I have to, I wrote it down somewhere because I had to do it twice myself. Yeah, but anyway, I don't want to get into that. Yeah, I would just argue that the problem is this then, so look, you still have to have two reference points. So you have to know, you have to have something to compare it to. So maybe, now that we have the technology, we have something to compare it to, because we can do an experiment over a 50-year period, where in the past that was a little more difficult. And then you could see the difference. But first, I can't concede that it's true that that's how fast we're going, because those calculations are based on redshift, which I don't think they're accurately understanding. And second, I'm still going to argue that you still don't have any theoretic argument to make that this laser beam, that the light coming out of it gives a damn about how fast this thing's moving. So if that speed is correct, and there's some implication to it, like over 15 feet this beam isn't shooting straight, then the way to calculate that is to use some other instrument to figure out what a straight line is and see how much it's off the straight line. I don't know any other way to fix it. I mean, we certainly know that it's pretty reliable that magnets are producing magnetism that's perpendicular, that electric circuits are producing perpendicular force. So, like I said, those things though are very short distances. So those short distances, even at that speed, you're not going to notice anything. So it's kind of hard to make magnetism shoot far enough for you to be able to make a calculation that it's off this. These angles are really small. It doesn't, it takes a lot of half the speed of light before you even have a 10% increase in the absolute velocity and enough of a change in the deflection, or whatever you want to call it. Alright, astronomers can now measure how fast the Earth is moving compared to this radiation filling all of space. So again, these are their axioms, that we can compare it to field microwaves or something, or some other force. And again, as I've stated before, then you're really getting into a mess. Theoretically, well, again, technically, he says, our motion causes one kind of Doppler shift in the radiation we observe in the direction that we are moving, and another in the direction opposite. Well, no, the truth is that you can emit light and shift it, and you can shift light as you're receiving it. So if the receiver's moving, it will shift the light in the sense that it's going to shift its interpretation of it. And if the emitter is moving, it's going to produce light faster just by the incidence of producing the photons at different locations. It's producing the photons forward of each other. So obviously the interval is going to be compacted between the photons. Put another way, the CBR, which I don't know what that means, provides a frame of reference for the universe So I guess that's something background radiation. For the universe at large, relative to which we can measure our motion. Well, again, I don't know how the... First off, I would argue that you can't measure its movement if you're moving, but whatever. From the motion we measure compared to the CBR. Well, again, how can you do that if we're moving? How can you know what the steady frame is if you're moving? And I mean, there's no way to... Well, anyway. We need to subtract out our motion from the Earth around the Sun and the Sun around the center of the Milky Way. The motion that's left must be particular motion of our galaxy through the universe. Yeah, if you can do that, it'll work. But again, I don't know who's got the tools to do exactly that, to be able to parse out all those motions, to figure out the net motion. But my argument is the net motion should be figure-outable just by shooting a laser beam at any target, and if you shoot it far enough, you should know by the wobble of the light which way we're moving in any dimension. So if you shoot it straight up, you'll find out that information. You shoot it left or right, you'll find out that information. And shoot it forward and back, you'll find out that information. You'll find out the three motions in the 3 dimensions, and you'll figure out you can do the math and add them up. Not add them up, but add them up vectorally. Okay, and how fast the Milky Way is moving. The speed turns out to be an astonishing 1.3 miles per hour, 1.3 million miles per hour, 21 million kilometers an hour. I'd rather do miles. So 1.3 million miles an hour. I don't know, what are you getting, 1/10 of the speed of light? I'm not sure. Let's see. The speed of light is 3 million meters per second. Oh shit. Well, no point in me trying to figure that one out. The miles per hour number I should have written down, because I had to do that conversion, I thought. Well, I think it was in the calculator. I don't think I bothered writing it down. Alright, we are moving roughly in the direction on the sky that is defined by constellations Leo and Virgo. Who cares? Astrosociety.org publications, well, whatever, the Astro Society. How interesting. Anyway, yeah, it just depends on the built-in assumptions. So again, I can't, I got to argue their assumptions. Fine. I'll just continue to argue that the implications of giving light momentum in any other directions is you're going to never have a consistent speed of light then. So that breaks Einstein's statement, in my opinion. You can't have this consistent speed of light if you're constantly giving light different momentums based on which way the thing emitting the light is moving. So light can't have more than one momentum, or it automatically moves faster than the speed of light. It automatically arrives at a location that is that has a perpendicular, has a hypotenuse that is longer than light is permitted to travel that distance. Alright, Piro doesn't lie all the time. Yes, he does. I would be suppose Piro doesn't get out much. Well, that's irrelevant. So, yes, Blue Jay, you're not very useful. If it were, let's see, so this is Mikhail Gumbovin or something. If it walks like an asshole and talks like an asshole, it's probably an asshole. It's not terribly impressive, but whatever. What's your take on Allen aspects, distance invariance in half-mirror separated particle core? I already did this Allen aspect thing many times. There's real problems with the theory, and the point is it's hard to find a page that has the actual data. So, and we never get to see his mystery mirror. You know, he apparently spins the mirror so fast that he can, on purpose, change the direction of a photon, to give it 2 different directions by turning a material mirror fast enough to change how fast a photon goes 10 meters. And that's really, I think, a bit of dicey bullshit. But the very idea of giving a photon momentum and then measuring what you just did to it, which is not momentum, but I mean creating an emitter that has momentum. Anytime you move a mirror, you're essentially creating an emitter that's now in motion, and that automatically changes, red shifts or blue shifts the light. So that's a problem, especially when you're doing this quantum entanglement crap. And then using polarized filters. So again, I've already made arguments about polarization. I'll make it real quick again. Polarization has a trick to it that will end up so it doesn't come out equal. In the sense that if you think of jail bars and you have frisbees and you're throwing frisbees through the jail bars, every single one you throw the wrong way bounces back. But not every single one you throw the right way gets through, because some of them hit the bars. And so that's the problem with, I think, using polarization filters, is that the polarization isn't equitable. The same number won't go through as get blocked. So if you have an assumption going in that they're equitable, then of course you're going to find a correlation of inequity, if that's what you're looking for. If you're looking for unequal results, well, you'll find unequal results because you have a flawed presumption going into the experiment. Okay. Time reversal theory, I'm not even going to bother with something that's silly. Campbell, Penrose, fuck them. Inflation, I don't give a shit about inflation. It's a stupid creation theory of the universe bullshit. So anyway, so none of that. Thank you. Please do not blow up the planet. Funny, I'm 100 goddamn with you. Who cares? I really just want relevant commentary. Thank you. Okay, a bunch of more irrelevancies. Here we go. You should debate this shit live. See, I have exactly the opposite impression. The problem with the live debate is that I say something sloppy and wrong, okay, and you have to go through a whole bunch of stuff on that one sloppy and wrong statement, and then somebody else ends up saying something sloppy and wrong because they're thinking off the top of their head, and they didn't anticipate something, they didn't have time to think it through, you know, they didn't draw a drawing and go through it and think about it for 10 or 15 minutes before they're saying what they're saying. So you just end up compounding each other's errors. So I think doing videos is much better as long as the other people will accept the premises you're arguing from, and accept that, okay, like if I say something like, well, regardless of what this relativity thing is, we know only one thing actually happens. There's one truth. Either the photons hit the hole in the ship, or they don't hit the hole in the ship. And then we can go from there. But this argument that it can do both is bullshit. And if you're going to say somebody else is seeing it differently, I'm going to say, well, that still doesn't work, because we can just create an experiment where they can't see it differently, in the sense that I put something in the way of the way you assume it to be. And then you have to concede that there's no possibility the observer saw it if the rule is the light has to go through the observer to get to the hole. He can't see it go straight to the hole if the light has to go through him to get to the hole. So that kind of thing. So I'm just saying, yes, this can work if people are arguing carefully enough, but in live conversation it doesn't work, because everybody's got to keep all of these concepts together, and then you have to figure out what specific thing you're going to argue. And then somebody just keeps bringing up new experiments and new, well, what about this, and what about that, and what about, and then you're really done. So I think this is the more rational way to debate anything, actually. And I think live conversation can be the most irrational way, except, I guess, when there's some overt mistake somebody's making or something. You know, like it's easy to argue with creationists in a live conversation. But that's a whole, you're just listing evidence then. You know, it's a completely different kind of argument. Alright, now this mindless marvel guys, I just can't understand his points. I don't buy the argument. So he's quoting me, saying I don't buy it. And he said, I already said in my previous comment that whatever light is released, it will be at such an angle where it would be aligned with the emitter while going to the right. And I already said in my argument that if you're going to say there's no such thing as a straight laser, I'm going to say it doesn't make any sense. Why don't I just change the position? If I know the laser is going to do something stupid, like the light comes out crooked, so I go this half the speed of light and I find out, hey, my laser's crooked. Well, I'll just point it back this way so I get a straight line. I'm just saying, and even if I conceded your point that the light automatically comes out crooked, you're still stuck with a diagonal line, okay? And it will go through the hole, but it'll only go through the hole if you give it more velocity. So you're still stuck with the same problem. You still have light going faster than the speed of light. And if it goes through a hole, it's still going faster than the speed of light. You don't have any mechanism to slow it back down. So whatever this bend was, whatever caused this, you don't have any unbend. There's nothing unbending it. And something needs to unbend it. Something needs to take away the momentum. You can't get to the hole if you say it's just bent and it's going the speed of light. That won't get to the hole. It has to go faster than the speed of light to get to the hole if it goes this way. If it bends to the future, it has to go faster than the speed of light to get to the hole. That's the problem you haven't solved. Jesus. All right. The guy in the ship would also be moving to the right with the ship. So yes, of course he's moving. Yes, the whole experiment's moving, yes. And he'd always be next to the devices, but the light will always be aligned with the device. You just said the light comes out this way, and now it's aligned. So which one is it? So the light wouldn't hit anyone. No contradictions, question mark. I don't know. Plenty of contradictions. At 1335, you drew a laser ray, but you didn't even account for the fact that the guy is also moving to the right with the ship. Again, it doesn't matter. The emitter's moving with the ship. Nothing's getting away from each other in the ship. We're just talking about what the light's doing and whether you can give it momentum. Damn. Can you make light go this way? Go this way and this way. That's the argument. Can the light go where the hole's going to be? It doesn't have time to get to it before it moved. The hole's definitely moving. Can the light shot here get to that hole in the future? And the point being made is there's no way it can do it without plowing right through the guy looking down and looking at it. Alright, well anyway. Alright, given this link, Wikipedia link, fuck. Classical electromagnetism. I don't know, why is this clairvoyant formulation of classical electromagnetism? Why are we doing this? That says the clairvoyant formation of classical electromagnetism refers to the way of writing the laws of classical electromagnetism in the form that is manifestly invariant under Lorentz transformations. Oh, Jesus Christ, what a pile of crap that is. Do you say Maxwell's equations aren't right, so they need corrections? Well, Maxwell's equations are for specific circumstances. Frankly, I haven't seen any Maxwell equations that apply to anything moving anywhere close to the speed of light. And we already know what happens to induction motors and lots of other stuff. Once they get to it, they have a speed limit. You can't turn the magnet and get anything out of it at a certain speed. The above link is lying. I don't even know what that means. I'm accusing somebody of lying because I don't agree with something. The above link got it wrong accidentally. I don't even know what that means. Alright, so well anyway, I'll go to your stupid link later, but fuck you, this probably doesn't have a damn thing to do with any of this stuff. Maxwell's equations are approximations. You can't detail the force interaction because it happens in a time interval. Everybody should understand that, right? One force causes the other force. It's all induction. So you always have to approximate something, and you have to approximate it within some sort of reasonable bounds. Once you start adding huge velocities to both items or both objects, the equations are going to break down. I mean, just doing the math to figure out a light bulb on top of a car. Not simple. Go back to read Pierrot's comments on an experiment light band. He challenges your assertion that he got his math wrong. He said, you show your math and he'll show mine. Well, the math, I'll tell it because it's not that complicated, right? So the idea is you have 2,000 miles of difference. So I just figured the miles of difference is all that matters. So it's 1,000 miles one way and 1,000 miles the other way. Now, maybe that's a wrong assumption, but I think that's the correct way to look at it. So we're talking about 2,000 miles of difference relative to the speed of light. So you take 2,000 miles and you divide it by 60, and then you divide it by 60 again to get miles per second. All right, so it's 0.5 miles per second. That's how fast 2,000 miles is, right? So it's 1,000 miles one way and 1,000 miles the other way. So then you have your ratio of 0.5 to the speed of light, which is 186 or whatever miles per second. And so for convenience, all I did was change it to 0.5 to a 1 and then double the miles per second, per hour. No, the miles per second, because we're on seconds. So I changed the 1 to get a 1 unit, is proportional to 372,000 units. So that's the unit difference. So you have to have a length of 372,000 to the amount that you're going to change. So whatever you make it, if you make it inches, then it's 1 inch to 372,000 inches. If it's 1 foot of difference, then you need 372,000 feet. And if you do the math for that, so that's just inches to conversion. So I did an inch conversion, which means you just divide 372,000 by 160,000, I think. No, I think that's centimeters. I think inches is 63,000. So you divide 372,000 by 63,000, and you get 5.9 is what I got. So you have to go 5.9 miles to see an inch of difference. And obviously you can break that down to 3 miles for a half inch, and then 2 miles for something like 4 millimeters, and that would be the total difference. So it'd be 2 millimeters on either side. So it's a pretty slight difference for a 2-mile length. So I'm just saying it is kind of a delicate experiment. It's not something you can do in your garage, I don't think, realistically. And mirrors would be nice, but mirrors get a little complicated in terms of the fact that the light is diverging and the fact that the mirrors are now moving. So that's part of fucking with the experiment in a way. It would be more ideal not to have any other moving objects in the experiment except for the emitter and the receiver, I would argue, just to keep anything from fucking with the experiment. But theoretically mirrors would be doable, but could be, but because you're only trying to measure the amount of wobble in the beam. But then you're, like I said, the spread of the laser is going to make the mirrors inefficient over a period of a certain distance. So I don't know how much distance you can get in a small mirror. You might get 4 rebounds before the beam is too wide to fit on the mirror. So that's sort of the problem there. But anyway, it's an experiment worth doing. It's not one you can do in a cardboard box. So those are my numbers for the record. 1 inch, you need 6 miles. Approximately. Alright, if I blink fast enough, a strobe light appears either solid on or solid off. And if I do the same in a comment section, Piro almost looks like he isn't spamming. Okay. Alright, so here I already read this comment, I think. Since we disagree about something this fundamental, it's actually hard to make a convincing argument. However, a good part is that we get to pin each other down on our positions. I could post a bunch of links. Yeah, don't do that. One of our counter arguments was 220. You said something about light not traveling the full distance and there not being enough time. I might have misphrased this, but I did not mean to. The light will be emitted at an angle such that the photons are moving up. Well, I just can't understand what the fuck you're talking about. The light will be emitted at an angle such that the photons are moving up. You mean perpendicular to the ship. like I said. Shit. But also traveling with the emitter. Right. Two velocities. Well, I don't know how you can travel. I just don't know how I can be going this way and going this way without it ending up going this way. I mean, not that you'll see it go this way. I don't even care. If you want to say you're going to see it do this, I don't think you're going to see the photon actually do that. I think it's going to do exactly what it does in gravity, which is take the perpendicular path. Man, you're being really irritating. But also traveling with the emitter. So again, like I say, he just gave it, so he gave the photon two momentums. It's both going with the emitter, which means it's moving half the speed of light this way and the speed of light this way. And it's doing the perpendicular of that, which is obviously much more than the speed of light. Matter is always slower than light. Well, no, well, obviously it's always, everything is slower than light. So that statement doesn't mean anything. So while the light has x direction, the fact that the component speed, what's a component speed, isn't the full speed of light, means there will be some component speed up. You can't have it both ways. You're saying now, what you're saying now? You're saying the light goes slower up to go the extra this. So we give it emitter direction this way, and somehow we make it go slower this way. So we break the speed of light this way. So we're not giving it another momentum. We take from this momentum and we make it go this way instead. And again, then your line is going to be too short. You don't have enough speed then to get to the hole because you're traveling a larger distance. Shit. Alright, so when the emitter gives light, I say it travels up, but it also aligned along the emitter. Well, again, if you either give it more extra or you take away. If you take away from the speed of light, you won't get to the target. Yes, you may reject this, yes, but I have a question. Have I said anything containing a contradiction so far? Yes. You have to travel extra distance if you're going to the future. It requires it. It's going into the well. You're going to go more distance. You can't do that going the same speed. It's not possible. You can't travel more distance at the same speed and get to the same location. If yes, everything below is garbage, I'm sorry. Else, I have more to say. I don't even know why this sentence was necessary. When you have an emitter and a hole on top, you give both the same velocity. We give both the same velocity. Yes, of course. But the emitter is irrelevant. The emitter, well, okay, it's not irrelevant to you because you're saying the emitter is giving the light momentum. I'm saying no. The emitter is just releasing light. It's not giving it any momentum. The light's going fucking straight. So it is fair to say that both move together. Well, says you. That's exactly what I'm arguing. If they're both moving together, then you have the diagonally line, then you have the faster than speed of light to get through the hole. They are aligned. Now, as the photon is emitted at the angle, such that it is always aligned with the emitter, but the emitter happens to be aligned with the top hole, so if you visualize this, it doesn't matter how long it takes the photon to get to the top hole. Yes, it does matter. That's the whole point. Because it is always aligned with the emitter hole, and it is going up along with the emitter top hole. But you're still ignoring the fact that, look, you're just saying, I'm just going to pretend the photon is doing this, and I don't have to account for the distance. The point is you always have to account for the distance. The point is you're going to arrive at a location, and that location requires you, the light, to travel a distance. And you're just trying to say, I don't have to account for the extra distance. Just like if I throw a baseball off a train, it's a longer path. Depending on where yes, because I'm throwing it away from the person, and it has to arc to the person because of the two velocities. So the baseball travels a longer path. Okay. So you can't ignore the physics of what you're arguing. All right. I'm in an angle, so it's always aligned, and it happens to align with the top hole. So if you visualize this, it doesn't matter how long it takes. Well, it always matters how long it takes, because it's always aligned with the emitter hole and is going up with the emitter to the top hole. Again, you're ignoring the physical implications of the sideways motion. So now you're not only giving something two motions, you're separating them in time. And, you know, that's really not legal. Because essentially you just said it moved the speed of light to the new location. It didn't take any time to go sideways. You're saying it takes time to go this way, so going up takes time, the speed of light. But going this way takes no time. So you just basically said it's moving the speed, it's moving instantaneously from here to here. So the momentum is instantaneous momentum. So you didn't just add the speed of light, you added instantaneous momentum. And that way you you got it through the hole, because just obviously adding instantaneous momentum fixes everything. But there is no such thing as instantaneous momentum. So you didn't really give it momentum, you gave it instantaneous, just make the photon jump without accounting for it as time taking. So he's just drawing a line. He's saying it's a dotted line, and the dots are separated by a distance, and we're not going to count the distance. The dots are separate. So he's doing this, 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 and he's not going to account for the time it takes to do this. So all he's going to count is the motion this way, and he's not going to count this as taking any time at all. Okay. All right. So if you can visualize how long it aligned with the top hole. This means it will eventually reach the top hole regardless of time distance. Well, again, it's just a silly argument. You're arguing that it will reach the hole because it traveled the speed of light, and it instantaneously had instantaneous sideways motion. Yes. Text can only carry so much info, so I wish I could make a drawing, make a video. Is there anything where there is a counter argument? I think there's no problem in the above text. Well, I can give you a place to post images if you want a place to post images. Now the real question is, why do I even believe this in the first place? And then classical, he's going back to classical electromagnetism. Alright, so I'll have to go to that link. He's posted it a second time now, like this is supposed to be something important, which I doubt. Alright, do you agree we are composed of photons held together by simple rules? Apparently he didn't get an answer to that one. Is it impossible to compensate for the angle? Let's see, I thought I would reply here. I don't know if we are composed of photons, but it is a possibility. Here I am agnostic. I do not think whatever rules of physics are, they would probably be simple though. Yes, very simple. Forces can't acquire momentum in two directions. Is it impossible to compensate for the angle? Well, here is what I and others are arguing. Say we have a device that creates light in the upward direction. Now we give the device speed. We don't reorient it. Then that same device will give off light at an angle such that the light will be aligned with the emitter. Well, again, the emitter is moving with the device. The device is the emitter. How can you just... It'll give off light at an angle such that the light is aligned with the emitter. Well, of course it's aligned with the emitter. Who's arguing that? Anyway. By this theoretical statement, I would say that it is irrelevant whether or not you can tilt the laser pointer. Well, so again, he's just saying that I'm not going to account for how long it takes to move sideways. I'm just going to ignore that. That's instantaneous, so we don't even have to worry about it. And that's all he's saying. He's just taking half the momentum away and just giving it instantaneous hopping. It just instantaneously hops to the new positions, and therefore it doesn't have to use up any time. Thanks for answering. My question came from the video. Gary, you asked, is it impossible to compensate? Okay. Yeah, so he's not really saying it's coming off at an angle. He's saying that the photon goes up in space, just jumps to this location, then goes up in space, and then just jumps to this location and then goes up in space. So he doesn't have to account for the time it takes to do the sideways motion. Okay. Fine, how are you? I am a huge fan of science growth thinking in general. I don't know if that's relevant. Demonstrates how difficult the task. Yes, that sure is. Okay, so these two guys are just talking to each other, so that's okay. So I already did that one. This is an important point. If anyone can prove that Amendum is suggesting this video wrong, it'd be amazing. Yes, well, that's before we found out I was a little bit premature in my declaration of the impossibility of lensing, but it still doesn't have a hope. I just have to prove it. Damn it. Anyway, I know you understand this already. This is just supplementary for others. The only way is that the admission wasn't actually perpendicular, but instead admitted at an angle. So basically, the person conducting the experiment was aiming the light at an angle to line up with the target, so that they would perceive that it was traveling perpendicular. Is something that only admits photons along a single path. However, the mistake in perception couldn't happen because they realized they were aiming. Well, let's all understand too, the mistake in perception is based on two made-up observers. So the real problem is that they have sort of straw-manned the observer outside the ship, because they've straw-manned him into the notion that he actually sees the light go through the hole, when what he should be seeing is, no, the light goes back, it hits the side of the ship, and the hole gets further and further away from the dot on the ship. The ship has a dot on it, and the ship just keeps moving over the dot. The laser just ends up going not anywhere near the side of the ship, because the side of the I just said it the wrong way myself. He sees it go straight, and all he sees is that the dot is up here. It totally misses the dot. It hits the side of the ship, and then the ship just moves across the dot. That's all he sees. What you would expect to see. The light travels straight. The hole left at half the speed of light, so it's here. The light hit back behind it, and the ship just continues to move, and the metal keeps flying across, and the dot just stays right there. And the emitter's here, the dot's here, it just keeps going. That's it. That's what happens. And so they say that the observer guy, is seeing this. When no, what the observer guy is seeing the light go straight up and hit behind the hole. He's not seeing any of this shit. He's seeing a straight laser hit the side of the ship 2 feet behind the hole. So I suppose that's enough. About the planet's delay, I haven't thought about this too much, but the immediate thing to say is that light coming off of the planets is a reflection of light. Well, again, reflection doesn't matter. Reflections are absorptions and readmissions, so that means they're essentially emitters. So they're going to redshift anything, and whatever, if you say there's such a thing as a momentum that can be imposed on light, they're going to impose the momentum. Yeah, there's no way of getting around it. I mean, even a sideways motion is going to be the wrong kind of motion, so that's going to break that interferometer too, because a sideways motion is still an absorption, and then it has to be re-emitted by something moving, and the moving thing is going to give it the motion, so it can't work. The question is whether sideways motion creates redshift, and that's the interesting question, right? As much as this is an interesting question, don't get me wrong, of light having momentum, another interesting question is, can something moving really fast, that you shine light on it, will the light get redshifted in the reflection? So it'd be interesting to spin a mirror really fast and see if the light's redshifted that bounces off of it, or blue shifted. Let's see. Yeah, so you just shine the light at an angle that hits where the stuff is moving, and then you have the light will come off that angle, and it should have a blue shift going with it and a red shift going the opposite direction. Yeah, so that would be an interesting experiment. I'll see if that's some. If somebody knows where that experiment is, yes, please post a link. A spinning mirror creating red shift, because in that way would mean that horizontal motion creates red and blue shift. I don't know how it could create blue shift. I guess it's the percentage of the angle from which you're looking at it. So it's the reflective angle. Ah, that's it. A reflection is always an angle. I wasn't thinking properly. A reflection is always an angle, so it's some percentage of a redshift. So it would have to be a much higher speed. The redshift wouldn't be commensurate to it coming directly at you. The redshift would be commensurate to the angle of reflection. So it would have to be like a 45-degree angle or some kind. It's always going to be some kind of angle. And the angle would take away half of the redshift. So it only redshifts half as strongly as something coming right at you. Yeah. Yeah, because you're coming in and then the light's coming at you at an angle moving. So it's the angle that moves. The angle, it can only impose the shift in the frequency commensurate to the angle. So the angle is going to, if the angle was straight, the redshifter would be easy. But if it's an angle, then that means the redshift is halved. Yeah, okay. So when they see something redshift, they can't think only in terms of forward and back. They have to think about motion this way. So that's where I'm saying they've miscalculated the speed of things in the universe, because the redshift isn't just created by things going this way. It's created by motion sideways. I'm just trying to think, because it depends on left and right then, right? That's where it gets. So when it's moving towards you from the left, it'll be blue shifted, and when it's moving away from you, your center to the right, it's red shifted. Yeah. Well, anyway, so it screws up. If it's true, it screws up what they are thinking when they see redshift. When they see something redshifted, it could have two velocities: one moving away from us, and one moving away from us at an angle, also going the wrong way, going away from the center. Yeah, coming towards the center would be blue shift, going away from the center would be red shift. There, now I got it right. So everything that's moving away from us and away from the center would be red shift, either way, moving away from the center. So going away would be red shifted extra, and everything coming towards us, even if it was going away, would be a combination of red shift and blue shift, and so all you would get is the net shift. Oh, that makes it even more complicated, because the shifts will combine. Well, anyway, if I'm right, that's why they have miscalculated redshift, because all the horizontal motion is fucking up the forward back redshift. Very clever, Gary. Yeah. Yeah, I think I got him on that one too. Yeah, I think I got him again. I got him. Yep. Got it. Okay. Right, yeah. Look, there's always been a problem with the redshift stuff, right? I mean, it's always been kind of suspect. That might be why. Okay, so, yeah, the universe is moving a lot slower than they think. Anyway, till next time.